All right, let's look at some more examples of substitution with systems of equations. So here we have two different equations, and what we're trying to do is we're trying to get the variable of one of these equations all by itself, because then we know that the other side of the equation equals just that variable. Then we can plug in all of that mess into the other equation and solve. So let's try to get y all by itself here. So that's step number one. Get one of the variables all by itself. And in this one, we're going to do y, so we're going to subtract 7x from both sides. And that's going to turn into y equals negative 7x plus 22. So now we know that y equals that. And we have a y right here. So we could just say, well, 6x minus 5y equals negative 28. And we know that y is equal to that. So we can change out, anytime we see a y, we can put this in there, right? They're equal to each other, so we can interchange them. So if we see a y, we can put this. If we saw this by chance, we could put a y. So we could say 6x minus 5 times, and then let's put in that y information that we have, negative 7x plus 22. And that equals negative 28. So now we only have one variable, and we can solve for x. So we have 6x, and then we distribute this in. So negative 5 times negative 7x is going to give us positive 35x. Negative 5 times 22 is going to give us negative 110. And then we have negative 28 on this side still. We're going to combine like terms. We get 41x minus 110 equals negative 28. Add 110 to both sides. We get 41x equals 82. Divide 41 from divide both sides by 41, and we get x equals 2. So we found that where these two lines cross, the x coordinate is 2. So now we take 2, plug it back into either one of these equations and solve for y. Let's go ahead and plug it into this one. So we say 7 times 2 plus y equals 22. So 14 plus y equals 22. Minus 14, y equals 8. So now what we found is where these two lines cross, the point that lies on both this line and on this line has an x coordinate of 2 and a y coordinate of 8. So our solution is 2, 8. And let's look at this one. So again, we're going to get one of the variables by itself. Let's get x by itself. So this one, we're going to add 7y to both sides. So we have x equals 7y plus 53. And again, it doesn't really matter which variable we get by itself as long as one of them is by itself. So we know that x equals 7y plus 53. So anytime we see an x, we can put in 7y plus 53. So we have negative 4x minus 5y equals 19. So where we see that x, let's go ahead and put in 7y plus 53. So negative 4 times 7y plus 53 minus 5y equals 19. So literally we just took this and plugged it in right there. Now let's go ahead and solve it. We distribute, so we get negative 28y minus 212 minus 5y equals 19. Now notice we only have one variable, so we can solve. So let's combine like terms. This becomes negative 33y. We add 212 to both sides, and we get 231. Divide both sides by negative 33, and we get that y equals negative 7. Okay, so we know that the y coordinate where these two lines cross is negative 7. So now we have to figure out the x. So if we put in y, we should get out the x for this. So let's put in negative 7 for y right here. So x minus 7 times negative 7 equals 53. So that's x plus 49 equals 53. Subtract 49 from both sides. And we get x equals 4. So at the point where these two lines cross, or the solution to this system of equations, x is equal to 4 and y is equal to -7. So this is the point that lies on both of these lines, this line and that line.